Welcome to another episode and video on my driving robot Discovery based on the fischertechnik TXT controller running embedded Linux. Last time I did several tests concerning signals, pulses modulation and pulses using the default firmware and the community firmware. I want to continue this time with it and see whatever I can make of it, because the results were not quite the same for both firmwares. I also made it so that all probes are now nicely connected. I hope it will be so that all probes stay on the places. I have added a little wire here, and I have added a connector like this right here to attach this probe, because the wiring is not that robust that it can take such a probe, it turns out, especially when it comes to the counters. Now you can see that the controller hasn't been powered on yet. It is freshly charged, the battery that is. So let's see whatever happens. And that isn't a good start to begin with. Now it powers on. I have 3 batteries in total, and I guess I will have to replace the battery at least once, but let's see. Anyway, it is powered on the default firmware, so now you see here that I am being connected. That is good. That means that I will use SSH to connect using this default useID and this IP address. And if you haven't seen last time, then this may come as a surprise. Point is that both my controllers issue exactly the same address, and I cannot change that on when using the default firmware. So in here I have to change the fingerprint. So first of all, now this is the address that I need. So what I'm going to do now is delete this one. And now it asks for a continuation, and I'm in. Now the point is, how does it run? Well, just by doing this, and then I'm very curious what I will see on the scope, primarily on this time scale of 5 milliseconds, a frequency of 200 Hz. So let's just do that. So let's see whatever happens. Okay, this means I need to adjust something, a time base. So why is that is a problem. That is a problem. The yellow probe has completely gone out. So I need to fix that. And in the meantime, the controller goes off. So those are more than one problems, more problems than just one, to fix. And then both come off. So apparently this is just a bit too much. And that gives me the opportunity to make a solution quite like this one, to reduce the weight that I put on these wires. And here is about the same, also to be pulled off. So I really need a solution like either this one or this one for the whole situation. So with that respect, another thing is, of course, why does it power off? Really strange. It hasn't run yet. Well, and you saw the signals. The time base is now 200 microseconds, and that means that the frequency is totally different. Let's focus on that a little bit. So let's take maxima, then we say let's take the oscilloscope with it, 200 microseconds times 10 if this is a notation. No, this is 500. Let's see, to float. Yeah, right. So I need 2 more, -8 or something like that. And float. Forget about this one. But this says 200 microseconds, which is 2/10 of a millisecond. 2/10 of a millisecond. 5 milliseconds is 200. So this is just 1/10 of that. So this is, you could say 2 kilohertz. That's very different. Yeah, this is a very different frequency. It's good to know. Anyway, that's for this one. Time to fix things. Alright, quite some fixing. First of all, I have decided to no longer put the probes straight to the cables, but to attach a connector with one again a staple as improvisation, and I put it in a connector and attach the probe to the staple just like I did here, and for this one and for this one. So with all these wires I am very curious what is going to happen now. First of all, I have to fire up the controller, and I was very surprised to learn by using Maxima that the frequency is not 200 Hz but rather 2000 Hz. When I want to see these signals, I may be off, but 200 microseconds is 2/10 of a millisecond, and when 5 milliseconds is 200 Hz, then 2/10 of a microsecond is is a factor 10 higher. So let's see if this is connected. Yes, I of course have to relog in, and let's see what happens this time. I'm very curious. I should hear sound by now. This is odd. They're not the same length. And this one is positive, while this is 1, while this is 0. Let me look. Yes, they are both. They are all set to 5 volts. So one unit is 5 volts. So this is, so to say, maybe 1 volt, and that is 5 volts. And these lengths are different. Well, no process is explainable because it's standing still. But what's the rest? And here, why is this one still up? Or put another way, why is this one down? Let's see again. Now it really doesn't do anything. The other way around. Exactly the other way around. Positive and 0, and this one is slightly larger than this one. While sonar is obviously being activated, so let me push the battery block that is holding it, or doing something with it, away. Let's do it again. Let's just do this again. Yeah. Nothing. Once again. Alright, now it stops because of the distance. But if you looked at this signal, quite garbled. Not driving in a straight line at all. What to do with this? Looking at the code. One point of analytics. First of all, this part of driving is happening right here. Or is it? You set a distance and you go. Now this is conditioning for contact. So this is conditioning for sonar. Here it set the distance of 100. So the question is, going back in the coder, right here, what use is this? I can let it be, but if the sonar is going, well, it drives 700 pulses measured by these two probes here, and after 700 pulses with sonar you set it to 100 pulses, 40, 64, etc. But then right after another, set speed, stop, and set speed. I think it may be worthwhile if I make this separate blocks. With this idea, I looked once again here. Well, this block, this part is milliseconds. Here we go into microseconds. So 200 microseconds is indeed 5 kilohertz. So very different frequency altogether than the frequency I was previously working with the properties of the motor that is used with this one. So this motor is, according to its properties data sheet, operating on a frequency of 100 to 200 Hertz. So if I measure this one, and for a nice visual I have to set it to 5 kilohertz, that's quite the difference. Anyway, let's see if the behavior continues with everything. And I think I should change this. And now it's set to 2 milliseconds. Now it is set to 2 milliseconds. Which actually 5 Hertz. Check again. So the pulses are being counted. And yet it goes in a very, very big curve. Is this indeed because of sync blocks? I can always try. I think I should. Then again, I want to see the behavior, because I want to know if the presence of these probes is of very big influence. That can be. The space is too small, so right now I'm going to leave it as it is, and I'm going to do a floor test. See if this is indeed exactly the same behavior. If not, I have to think something of these probes. If these are such a heavy weight, because they are quite weight, and see if that shows something. Alright, so a floor test, and as you can see there are of course no probes for the oscilloscope, but also very different surface. I haven't changed the software yet, so let's first see how this is behaving. There's no diversion at all. Just a nice straight line. So this raises the suspicion that the probes are a very heavy burden and draw it to the right, although I remember for last time that it took a very different turn as well. So let's just do another test. Blocks a little bit further away. Roughly the same distance. And it gave an error about the lamp stop, but I'll ignore that for now. Second attempt. And here we can speak of a very clear diversion. No sound, but a very clear diversion, so that is not quite alright. Alright, on the middle line. Trying again. And yet another diversion. A very clear diversion. So this raises the question, although no sound, it looks like that I should try the software and see if that indeed helps, because with these diversions you can't but conclude that it isn't going to change. Although it is remarkable that diversions are constantly in the same direction. But that may be a coincidence. Anything else to conclude? Well, no sound. That's something that is a repeating factor. But yes, time to change the code. So I have changed the code for the sonar between 10 and 15 centimeters, and actually this is about that distance, so that should work. With the other distances it's not necessary. So let's see how this works, and I have not attached the probes, so here you won't see anything. And then I don't want to see that. And this is a diversion to the right. Not what I want to see either. So, is everything set right? I do think so. Let's just do another try. Camera thread. Yeah, I know there's no camera on it, but it doesn't matter. Look at that. It's backside and it up against the tripod of the camera, but apart from that, without sound, it did what it had to do with a slight diversion. I did though one other thing. I inspected the results of the waveforms, and I found out that the control, so the motor control, these lines were identical. The returning pulses were not. So that means that with the probe attached, and that is of course independent of the presence of the probes, there's a problem. So I do not think the probes are a cause of the big diversion. This went well. The floor test went quite well, so I still have to do more tests about it. What next? One more test here. See if this indeed goes straight. No, not that. This one, I hope. I have to do a test on longer distance. That's the point. And I can't do that in this setting. I can't do that in this setting. I will attach the probes one more time. And then see whatever happens. So and this one goes right here. It slides off too easily. This one right here. It is a little bit of a mess. And in the meantime the controller has powered off. So that's not very nice either. Alright, let that be. And now you see immediately that the lines are not very stable. So I think I should connect them at the crocodile beaks anyway. That's better. And it's off again. And I without power. I'm very curious. No, I'm in. So one more here with the probes. I have to log in again. If it lets me. Oh, it's still negotiating. Now it is. Yes. Quick run. This gives food for thought. But on the other hand, you see how uneven these pulses are. So let me do it this way, and lifting the probes. See how this ends up. If it ends up anyway. Anyhow. Not like this. Well, a diversion anyway. And uneven pulses from and uneven pulses from the motors. So final test on the floor, larger distance. And to end this episode, 2 short runs with a remarkably longer distance, and see whatever this works. Starting the program. So much for a straight line. Although that kind of works without the sound. So let's try the final one. and that was a display flash. And the program keeps on running, which I stop and I press enter again. Not a straight line, but not as curved as with the probes on them. So now I'm not sure what to think about it. Anyway, conclusion is in any way that the pulses that are returned to the controller, as I think it happens, are not synchronized. They are not synchronous. The pulses modulation from, assuming that it is indeed pulses modulation, but I think it is, from the controller to the motor is identical, so that's not a problem. Then I changed the time base, so I think it is a 5. I think the frequency is a bit higher than previously thought, although the motor runs, and I mean that motor runs as well, which according to data properties or data specification is about maximum 200 Hz, so not quite sure what to think about that. And that's it. Thanks for watching. If you like this video, please subscribe to my channel if you haven't done so already, and like the video. Follow me on Twitter and like and retweet, and follow me on Instagram and like. Please also donate to keep videos coming your way. For more information, please see my website, and this is going to be continued. Bye bye.